session today. Let's start the class. Let us start the class. Let's begin with the class. Okay. So today we have a fourth session. Today I would be discussing about water content determination. This is the first testing that is done in lab after sample is brought from the field. How do we do this testing? That we will see. See, in Geotech there are a lot of testing that you will do. So through this lecture we will see what we need to focus while we study any experiment. First of all, you should focus on aim, then procedure, then scientific basis behind the procedure, then observation, calculations, and then results. The scientific procedure is very, very important here. So let's see today. Today, few tests I will discuss on water content determination. Let us begin our lecture. Let's begin our lecture, my dear friends. So this is our lecture number 4 on water content determination. Okay. Let's begin. Let's begin. So water content determination, the various methods that are oven drying method, pycnometer method, sand bath method, alcohol method, torsion balance method, calcium carbide method, and radiation method. Today I will be discussing only two methods. Those are the most important method, that is oven drying method as well as the pycnometer method, which is asked in your exams as well. So today I will be discussing both these methods in detail. Let's begin our discussion. What do you say? Let's first talk about the oven drying method. Oven drying method is very simple. What do we do here is, in oven drying method, what do we do? Okay. First, what we will take is, we will take a empty pan, empty container. You will note down or record the weight of the empty container. Let's say that the weight of empty container is W1. Then keep this empty container and fill it with soil. Fill this empty container with a wet soil and record the weight, that is W2. Now keep this container with wet soil in an oven. It's a lab method because this oven can be operated only in the lab. It can't be taken in the field. So now put this sample in the oven and heat it at a controlled temperature of 105 degree to 110 degrees Celsius. Okay, at least for 24 hours. After 24 hours, pull out this this container and record its weight when the soil is completely dry. So weight of the container plus dry soil is W3. So this is the weight of the container plus dry soil. Got my point? Very simple till here. So W1 is the weight of empty container, W2 is the container plus wet soil, and W3 is the weight of container plus dry soil. Now what is water content? Water content is weight of water by weight of solids. Now difference in weight 2 and weight 3 is nothing but the weight of water only, na? So W2 minus W3 is weight of water, and weight of solid is weight of dry soil. That is W3 minus W1. So this is how you can calculate the water content using the oven drying method. So with these three readings, you can easily calculate the water content. So W2 minus W3 is the weight of water, and weight of solid is, that is the weight of dry soil, that is W3 minus W1. So like this, we can calculate the water content using the oven drying. So this is very simple method. First test that you might have done in your lab. Okay, this is the first test that you have done in your lab after sample is brought from the field. Now, there are a few points that I need to discuss here. First point, why we need to heat the soil in this range, or why we need to heat the soil only. Why don't you just air dry the soil in sun? So just by air drying the soil in the sun will not give me a dry soil, because air dry soil will have some hygroscopic water, that is adsorbed water left. So soil has a very large affinity for water. Okay, soil have a very large affinity for water. So to evaporate or to remove all the water, you will have to use an oven, and the temperature will be maintained at 105 to 110 degrees Celsius. Now you will ask me, sir, why the temperature is maintained between 105 to 110 degrees Celsius? Let's see this point as well. See, the water here is bonded with the soil surface. Okay, so just by heating the soil at 100 degrees Celsius will not remove the water completely. We need to supply extra energy, because 100 degrees Celsius is the boiling point for free water. So if you want to remove this water, you have to heat it more. So heat it at a controlled temperature 105 to 110 degrees Celsius. Okay. Heat between this range 105 to 110 degrees Celsius. Now therefore you have increased the temperature above 100 degrees Celsius. Now you would ask me, sir, why to wait for 24 hours? We can increase the temperature to 180 or 200 degrees Celsius, and in 15-20 minutes the soil will be dry. But I will say, no, my dear friend, you should not do this. Why? The temperature of drying should never be greater than 110 degrees Celsius. Why? See, the soil as well as water share a very good bond, and the bond is so strong that water starts participating in the molecular structure or crystalline structure of soil, and that water is known as water of crystallization or the structural water. While calculating the water content, we should not remove that structural water, because if that structural water is removed, the basic structure of soil will change. So when you heat the soil at temperature above 110 degrees Celsius, this structural water will be lost. Therefore, you will never increase the temperature of drying above 110 degrees Celsius. What's my point? So air dry soil does have hygroscopic water, whereas oven dry soil does not have the hygroscopic water. It is a lab method. As I told you, this method is done in lab. Weighed moist soil is dried in an oven at a controlled temperature of 105 to 110 degrees Celsius for a period of 24 hours. Temperature above 110 degrees Celsius may result in the loss of chemically bound water of crystallization, that is the structural water. Water of crystallization is the water in the molecular structure. Its loss may cause a change in the structure of soil. See, for organic soil, if you heat at such a high temperature, 105 to 110 degrees Celsius, the organic solids will get oxidized into carbon dioxide as well as water. So you will never heat the soil at the organic soil at such a large temperature. For calculating the water content of organic soil, the temperature of drying should be between 80 to 60 to 80 degrees Celsius. Okay. So for organic soil, the temperature of drying in oven is controlled at 60 to 80 degrees Celsius to avoid oxidation of organic matter present in the soil. Now you will ask me, sir, then at this controlled temperature, all of the water will be not lost? Yes, you are correct. At this controlled temperature now, all the water will not be lost. So how you will do the accurate testing? See, for organic soil, we don't operate at a single moisture content. We take the water content readings at various temperatures. At different temperatures, the water content reading will be different. Now, using a graphical approach, that is not in your course. Actually, we are not interested in organic soil because they have very poor engineering properties. But to determine the water content of organic soil, only one reading will not be sufficient. You have to record the water content at various moisture content, and then by using a graphical method, you can easily determine the water content of organic soil. Got my point? Now next is the pycnometer method. Now let's talk about the pycnometer method. So what is my pycnometer method? Let us see this pycnometer method. Is it clear till here? Please see till here. If you have any doubt, please ask me. Then I will proceed towards the next method. That is the pycnometer method. Okay. Am I okay till here? Do you have any doubts? Please ask me. Then I will proceed further towards the next method. That is the pycnometer method. Any doubts till here, my dear friends? Okay, no doubts. Let's see the next method. The pycnometer method. Very interesting. So pycnometer is nothing but a bottle like this. Using only this bottle, you can determine the water content of it. Let's see. Very interesting method. First, what you will do, you will take an empty pycnometer. Record the weight of this empty pycnometer. Fill this empty pycnometer with the wet soil. Record the weight of the empty pycnometer plus wet soil. Now fill this wet soil and fill this pycnometer with the wet soil with water completely. And using a vacuum pump, a special vacuum pump that can be attached here, using this vacuum pump, you will remove all the air entrapped. There should not be any air, only solids and water. And record the weight, W3. Now wash the complete assembly and fill it with water again and record the weight of pycnometer with water. So these 4 readings will take around 15 to 20 minutes. And using these 4 readings, we can calculate the water content of soil. Now let's see how to calculate the water content of soil using these 4 readings. Very interesting. Shall I proceed? Yeah. Let me proceed now. Okay. So using these 4 readings now, I will be calculating the water content. Let's see how we will do this. Very interesting and very simple. Tell me now one thing. What is water content? What is water content? That is nothing but the ratio of weight of water to weight of solid. This is my water content. Water content is what? That is ratio of weight of water upon weight of solid. This is my water content. Weight of water is how much? That is W2 minus W1. This is weight of soil minus weight of solids divided by weight of soil. This is my equation number 1. Or this I can write like this, that is W2 minus W1 upon Ws minus 1. This is my equation number 1. Now if I am able to determine this water weight of solids, my job is done. Now using this W3 and W2, you will determine the weight of solids. How? So if from W3 weight of solid is removed and replaced by water having volume of solids, then you will get W4. In W3 we have only solids as well as water. So if you are removing solids and you are adding equal amount of water, then you will get W4. This first I will write it in statement. If from W3 solids are removed, are replaced by water of equal volume, then we will get W4. So if from W3 solids are removed, see W4 is what? W3 minus weight of solids. Now what you are adding? You are adding water having volume of solids. Huh? So replaced by water of equal volume, then we will get W4. So W3 minus Ws. And you are adding water that is having volume of solids. So this is my volume of solids. This is my volume of solids into gamma W. This is the weight of water having volume of solids. So here Ws by or Vs gamma W is equal to Ws by Gs gamma W into gamma W is what? Weight of water having volume of solids. So my pycnometer will be again full and the weight that you will record is W4. You are not doing this actually. You are just imagining. Now from this equation you can easily calculate the value of Ws. What is the value of Ws you are getting? So this implies Ws 1 minus 1 by Gs is equal to W3 minus W. I can write it. Just keep it here. Ws common. 1 minus 1 by Gs. W4 will go that side. So this implies Ws is equal to W3 minus W4 into Gs upon Gs. Now substituting in equation 1, substitute it in equation 1, you will get the water content. Substituting in equation 1, we can write water content is what? W2 minus, now remember this formula my dear. W3 minus W4, Gs minus 1 by Gs. This is how you can determine the water content using the pycnometer method. Very simple method. Like this you can derive. Very simple. Okay. So just make a note of it. Then I will proceed further. Okay, my dear friend. Please see to it here. This is pycnometer. Please see. Any doubts you can ask me. Then I will proceed further. Okay. If you have any doubts, you can ask me here. Then I will proceed further. Correct till here? No doubts. Let's proceed further. Now see here, I have introduced an unknown, that is GS. Unless you know the GS of the soil, you won't be able to determine the water content using the pycnometer method. So we will use the pycnometer only to determine the GS of the soil. Let's see how to determine the GS using the pycnometer method. Unless you determine this GS, you won't be able to determine water content. And one more, do you think you should understand that pycnometer method is a lab method, and it is very quick method. Now you don't have to wait for 24 hours. But given that you know the GS of the soil, then only. Okay. And this is suitable for coarse grained soil, not for clays or fine grained soil, because in the case of fine grained soil like clays, removal of this entrapped air is very difficult. So it will introduce some errors there. Okay. So in pycnometer method, we get quick result, but it is important that all the entrapped air is removed. So we have to remove all the entrapped air. So removal of entrapped air is difficult in clay soil or cohesive soil. Hence, this method is not suitable for cohesionless soil. So hence, this method is suitable for cohesionless soil, not for cohesive soil. Cohesive soil means sticky soil, fine-grained soils. Cohesionless soil is like sands and gravels, which will not stick. No attraction between the particles. Before calculating water content using pycnometer method, we must know specific gravity of soil. Now let us see determination of specific gravity using the pycnometer. Now let's see how to determine the specific gravity of soil using the pycnometer method. Very simple. Okay. Again, I will use the same diagram. Again, I will use the same diagram. So determination of GS using pycnometer. Let's see how to determine GS using the pycnometer. Let's see. Very simple. Just focus on it. Determination of GS. Using pycnometer method. Let's see how to determine GS using the pycnometer. So here, instead of the dry soil, I will take the wet soil. Okay. Instead of dry soil, I will take the wet soil. First of all, here you will not have the dry soil. You will have the wet soil. Sorry, you will not have the wet soil. You will have the dry soil. First change will be this one. So here we should take the dry soil. Rest the total method is same. So first we will over dry the soil. Record the weight of empty pycnometer. Record the weight of empty pycnometer plus dry soil. Then fill it with water and record the weight. And then wash the whole assembly, fill it with water and record the weight. Now let's see how to calculate GS. Very simple. GS is what? Gamma S upon gamma W. Gamma S is what? Weight of solids by volume of solids into gamma W. So this is nothing but weight of solids, and this is weight of water having volume of solids. Having volume of solids. That is weight of water having volume of solids. Here. Now let's see how to calculate this. WS, so you can calculate WS is simply W2 minus W1, that is weight of dry soil. Now weight of water having volume of solids. How you will calculate? First W4 minus W1 you take. You will get this much amount of water, weight of water. W4 minus W1, you will get this much amount of water. Now from this much water, remove this much water, you will get this much water which is having the same volume of solids also. How you will do this? So W3 minus W2 will yield me the weight of this water. So just subtract this weight from the earlier weight. That is W3 minus W2. Please look here. Like this, you can calculate GS also. So what I have done, very simple. First, I have taken W2 minus W1, that is weight of solids. Now, weight of water having volume of solids. For that, what I have done, W4 minus W1, that is the weight of water. Now, from this much water, subtract this much water. From here, I have subtracted this much water. You will get weight of water that is having volume of solids only. So now W3 minus W1 will give me this much amount of water. Subtracted from W4 minus W1, you will get the weight of water having volume of solids, and that will be my GS. So using the pycnometer method only, you can calculate the GS also. Please see to it once, then I will do certain event. Very simple. So this was all about the pycnometer. I guess it's very simple. Eh? Now let's see some questions. Okay. Now let's see some questions on these concepts. Do this first question first. Do this one first. Simple question on pycnometer. Please solve this. Do this first. First solve this question. Make it fast. I am waiting for. I am waiting, my dear friend. Please tell me the answer. I am waiting. Okay. Please solve it. Make it fast, please. And we will also solve for you. Okay. Please solve it. Please solve. Done. Now let's solve it together. Now see what is being given to me. Very simple question. Let's try to solve it together. Question on pycnometer. This is my calculator. My calculator. You can't see my calculator here. Please solve it fast, please. Okay, there it is. So weight of empty pycnometer was given to me. W1 is the weight of empty pycnometer. 550 grams. W2, W4, everything was given and GS was also given. Let me just write down the formula for what? What was it? That is W2 minus W1 upon W3 minus W4 into GS minus 1 by GS minus 1. So W2 is how much? In grams. Everything is grams. 950 minus 550. Then 1650 minus 1480. 1650 minus 1480 into GS is how much? 2.65. Multiplied by 100. You will get your answer in percentage. How much you are getting? That is 46.50%, right? Got it? Very good. Great. 46.50% is the correct. Let's see one more question. Try to solve this one. This is also very interesting question. On organic soil. Please try to solve this. I am waiting. You will take time in this one. So just try to solve this one now. Okay. Chalo, let's try to solve this question. Okay, let's try to solve this question. Very simple. So mass of empty pycnometer was given to me. This is the mass of empty. Sorry, mass of empty container was given to me. Here you have an organic soil. To the recorded observation here, W1 is 40 grams. W2, that is mass of soil container plus wet soil, is how much? 100 grams. And mass of oven dried soil will come out to be how much? That is 85 grams. Now in the oven dried soil, erroneously maintained at 10, organic soil should not be heated above 80 degrees Celsius. Otherwise, the solids will get oxidized, okay, causing a 5% loss in the true dry mass of the soil due to oxidation of the organic matter. What is the true water content of the soil sample? Okay, so let's see what is the true water content of the soil sample. Let's see this. So 5% loss have occurred, so we have to find out the correct weight of solids. The weight of solids is what? W3 minus W1, that is 85 minus 40, 45 grams. But WS dash is equal to into 0.95, that is 100 W, because 0.5% is lost here. Okay, so 100 minus 5% divided by 100 is equal to my WS. So WS dash is equal to how much? It is 45 upon 0.95. This is actual weight of solids by taking account the organic solids that have evaporated. So 47.368 grams. Now water content is equal to what? Weight of water by weight of solids dash. Weight of water is how much? That is W2 minus W1 minus WS dash this time upon WS. W2 minus W1 minus 47.368, 47.368 into 100%. So how much water content you are getting? Very interesting question, but simple only. Okay, it was not that tough. Point 266 into 100%, that is 26.67% is the correct. Clear? Please solve this. The correct answer is 26.67. The nearest answer is D. So D is my correct answer. So these kind of questions you can very much expect in your exam section. Okay, my dear friend. So this was all about water content determination. This is my Telegram channel. You can see. You can connect with me out here. Thank you, everybody. Bye-bye. Take care.